focus your attention on what's inside the parentheses. What expression is going on inside the parentheses? I'm going to start you off slow and we're going to build. Michael Lepsche. Okay, great. Everybody see definitely addition inside the parentheses? Of what two numbers? 20 plus 30. Everybody agree? I want you to think of what's going on inside the parentheses. Call this the set. It's like a set of 20 plus 30. Put it right above it. Set. Meaning there's a set of two numbers being added together, in this case 20 plus 30. The number outside the parentheses, this 2, circle it. I'll color code it. That tells you how many there are of the set 20 plus 30. I don't know if this has been taught to you down in elementary school or not. It might be new. But that number outside the parentheses tells you how many copies or how many sets there are of what's going on inside the parentheses. So in this case, how many sets are there of 20 plus 30? Gabby? There's 2. Watch how I model this. I'm going to put it off to the side. That's one set of 20 plus 30. And here's like a photocopy, another set. Make sense so far? Yes or no? We're good? All I did is just made a photocopy of it. There's 2 copies of it. Put like little boxes this way. We're going to add up. All of my 20s make how much? Good. Keep the plus sign as is. All of my 30s make what? What we just did is called using the distributive property to rewrite the new expression. Now, I don't know, do you see kind of the shortcut? I took my 2 outside the parentheses, and I multiplied it by 20. Since there's 2 sets of 20 and 2 sets of 30, right? 2 times 20 makes, hey, I like you there. 2 times 20. Right. And 2 sets of 30, 2 times 30 makes? 2 times 30 makes? Correct. Now we can add 40 plus 60 to make it standard form. 70, what's 40 plus 60? 100. Circle it. And it kind of makes sense too. Watch what happens when you evaluate the set or the thing that's going on inside the parentheses. What's 20 plus 30? Just say it out loud. And if I told you there's 2 sets of 50, what's 2 times 50? You wind up getting the same answer. See, it seems like right now it seems like the long way to get an answer, but the reason why I'm showing you with numbers is what it really has to do with lesson number 8, which is really being able to do it now with algebraic expressions, which we'll get to. But I'm going to start off with the same for every one of these. I'm going to ask you, what's the set? How many there are of the set? So let's see, Skylar, what's the set for number 2? 8 plus 5. Amanda Johnson, how many sets are there or copies are there of 8 plus 5? 6, right? You don't have to do this, but I'll just show it to you so it's visual so you can see it. I'll write it out 6 times. Yes, well, 8 times 6. Watch what we're going to do. Yes, that's the shortcut.
Wait, 8 times 6? I thought it was 8 plus 5.
I had 8 plus 5, right? And I made 6 sets of it. 1, 2, 3, 4, 5, 6. How many sets are there of the 8? So technically, if I add up all the 8s or take 6 times 8, what do you get? So I have 48. My plus gets untouched. And 6 sets of 5 make? Right. So in essence, what Tyler's just saying is what I did is like, instead of having to model it all out, I did 6 times 8, show it with an arrow, plus 6 times 5.
Yeah, but 8 plus 5, 8 plus 5 times 13.
Right. You can, but you're not doing distributive property that way.
Oh, yeah.
Because it's going to eventually be done with variables, and it's not easy, and usually you cannot come up with a numerical answer for it. Simonelli, what's the set for number 3?
3 plus 5.
Right, Joe Domino, how many sets are there? Now, I'm not going to make 12 sets of this, so we'll take the shortcut. 12 times 3, everybody.
36.
Thank you. 12 times 5. Oh, by the way, going back, I forgot to evaluate this in standard form. 48 plus 30. Amanda. Good. Circle it, nail it down. And finishing up the last set. 12 times 10.
120.
Good. Add it all up. Tell me what you get. Brando, what'd you get? Just got to add carefully. Make sure you digits line up. 36 plus 60 plus 120. Joey Lombardi. Yeah, 216. Very nice. Chris, number 4, what's the set? How many copies are there of it? 2 times 15, everybody.
30.
2 times 9, everybody.
18.
2 times 7, everybody. Crunch it and munch it. What do you get? Sounds good. 62. So now when you look at number 5, I'm still going to ask you what's the set. And I'm still going to ask you how many there are of it because you know how to combine like terms. What's the set? How many there are of it? Here's how I model it. Skip down. I have A plus B. Make believe like they're little tape diagrams or variable tiles we've used. And as Lucas Longo said, there's 2 sets of it. So you model it by showing 2 sets, or a copy, 2 copies of A plus B. Now you remember, or maybe you don't remember because it's been a weekend, when you're adding variables, they have to be the same letter. You can't make A and B. It's like apples and oranges. You can't squish them together to make one fruit. So I like to line up. I have a column of all A's and I have a column of all B's. That I can do. Thorny, 1A plus 1A. 2A. Luke Soresco, 1B plus 1B. Therefore, if you use that little multiplication trick here, like I showed you back with the numbers, 2 times A is
2A.
2A, plus 2 times B is okay, ready? Repeat after me. Circle this. Can everybody say factored form?
Factored form.
Circle this. And say expanded form.
Expanded form.
Now, if you write it out, then we could skip the top of page 3. All right. Basically, when you see the parentheses in your expression, it's already been in what we call factored form. If you don't see parentheses, it's in expanded form. Okay. It would be. Technically, I'd have to write this out as this way. Let's just say it's expanded a little bit more, but not all the way. Okay, it's a good point, though. Yeah, and that's okay. Yeah, it's okay. All right, definitely not factored form, though, because your parentheses are an indication that it's factored form. Can I go to the next page?
Yeah.
What I just explained is all here. It's kind of your definitions of what's what. We can prove that the two forms, this is the factored, this is the expanded. How would you prove that those two expressions are equivalent? How would you prove that they are equal? How would you prove that they will both work? What do you do, Joe? What do you do anytime that you want to prove? Right, you what's the S word? Yes, you substitute. Very good. I even give you the values for A and B. All right. Joe, what's the value for A? No, bud. Two sets of, what's the value for A? Tyler, what's the value for B? Now, from this point, you can use PEMDAS. What would you normally do first if this was a PEMDAS expression? Try it. Okay, do it. 3 plus 4 is? There are two sets of 7, which is really multiplication. Very good. Thank you, Chris. 14. Substitute here. 2 times 3 plus 2 times 4. We could do multiplication in the same step. 6 plus 8. Punch it all together. Both expressions are equivalent. One's in factored form, one's in expanded form. Want to practice? Example 2. Example 2 is expanding expressions. They start in what form? What form is this? Brando. Factored form is correct. Write it out. Very nice. Parentheses is your hint. Stace, what's the set? How many copies of the set? How much? I'm going to create 2 sets. 3x plus 4y. Keep your x's lined up nice. Keep your y's lined up nice. This will be important too, as you'll see. When you're doing expanding factored forms, you'll see there'll be multiple variables. It'll get a little bit more difficult. If you line up all your x's and line up all your y's and line up all your z's and all your a's, it'll be easier. Skylar, how many total x's? Aiden, how many total y's? Very good. Factored form, expanded form. Yes. Okay, show me fingers. 5 means you totally get it up to this point. 1 means you totally lost. 3 is in between. You must vote. 4 is good. 3 is good too. 3 means we're getting there. 2, I'd have to stop and go back if you're not quite getting it. So I see a lot of 3s, 4s, and 5s, which is pretty good. Okay, good so far? We're going to go backwards now. We're going to go from expanded to factored. Watch, it's actually even easier than going the other way, you'll see. Watch. Oh, this we did. I'm going to skip 5 for now. It's just proving that both expressions are equivalent. They are, so let's just move on. Go to example 3. What form is this? Don't call out, but yes, expanded. No parentheses. That's your hint. Okay, so now this is new. You have two terms being separated by an addition sign. Okay? What coefficient, or do you see a coefficient that is the same in both terms? And if so, what do you see that's common in both? Nick. They both have 5. Ready? Repeat this after me. When you see it, factor it out.
Factor it out.
When you see it,
When you see it,
factor it out.
factor it out.
5.
5.
Okay, you don't have to repeat anymore. But thank you. 5 is what's common in both. When you see it, factoring it out means that's the number outside the parentheses. So 5 is going out, parentheses, and I know I need a plus sign in the middle. And you work backwards. 5 times what makes 5a? Giuseppe. Correct. An A in. 5 times what makes 5b? Amanda. Done.
Wait, what? Isn't it Y?
Oh, yeah. Why? Sorry. I saw Ryan Levine's looked at me like I had 3 heads, and usually he's pretty good at this, so I probably knew I made a mistake. And it works. So if you work forwards again, 5 times A is 5A, and 5 plus 5 times Y is 5Y. It works. Show me fingers.
Mr. Rossi, I just have a question.
Mm-hmm.
If it's, now how you said you can't add together the variables? Then
What?
Why would you add them together?
Say it again. Not too close. Yeah.
I thought you said you can't add together variables.
Yeah. I have it. I still have 5A plus 5Y. I can't go any further than this. I can't combine it. Okay. I can't make this any smaller. I can't combine my terms. It would have to stay 5A plus 5Y. And this has to stay this way. Oh, yes.
Jack said it wasn't entirely like when it was like 6x like plus 8y. It kind of is when you see a number of variables and multiply.
Right. She's just I'm just leaving out the dots. She says to fully expand, you put the dots in, which is fine. Still the same thing. Okay, good so far?
Yeah.
Something sort of new. Take care of the basics first. 3x plus 7x. Expanded form or factored form? Take care of the basics first. Correct. No parentheses, so expanded. Now, I'm just curious. Do you know what to do now? Something's got to get factored out. Do you have a number you see in both terms that are the same?
No, sir.
No, you don't.
However,
But what do you see, Nick? You do see a variable that's common in both, don't you?
yes.
Hold off the Sharpie, Nick. When you see it, see, you forgot already.
When you see it, factor it
When
out.
you see it, factor it out. First of all, there's not a common coefficient. There's no common number, so no. Yes, I see a common variable, which is x. When you see it, factor it out. X comes out. Work backwards. Tell me what goes inside the parentheses. Trick question.
Oh.
Go ahead, do it, because I have you write it out. Go put it up. Looks good. Let me say 3 plus 7. Now, let's just do let's take stock of ourselves. Look at what you guys are doing today. Think about 2-3 weeks ago. Look how far you've come with this. You wouldn't have been able to do this 3 weeks ago, am I right?
No.
This is pretty amazing that you're starting to get it. It's like learning a new language. Now it's like becoming like second nature to you. When I say 3 times x, it's 3x. It's becoming natural to you, which is good to see. Yes, sir.
Hey, you can say that.
Hey, there we go. Just Tyler being Tyler. It doesn't matter, but since they appear in the first term as a 3 and the second as a 7, just keep the order. Okay, now watch this. Can you combine this?
Yes.
To what?
To 10x2.
No, be careful. 10x, right? Right? No,
10x.
it's 10x because you're not multiplying, right? Do you all agree 3x plus 7x is 10x? Watch this, ready? What's 3 plus 7?
10.
It would be. What's 3 plus 7?
10.
What's 10 times x?
X.
10x. Okay? Different ways of making the same thing. It's like making change. You know, if I ask you have 39 cents, there's lots of different ways you can make 39 cents. Right? Thank you very little for that little. No, not on this. This is all just addition, subtraction. All right, go to set 1. Set 1. I'm going to do a couple, and then I'll do set 2, and really that's what your homework is. It's going to be the bottom of page 5, and I believe the top of page 6. Well, let's just practice it. No, it's not. It's not. It's not. All right, let's do the first 2 together. Aiden, you're the man. What's the set? Correct. Luke, Ceresco, how many sets are there of x plus 4? Okay, so the easy way, and I do want you to show it this way, 3 times x is what? Right, see, it's coming natural to you now. I asked you that 2 weeks ago, you look at me like I'm crazy. Nick Mirabella, 3 sets of 4 or 3 times 4 is how much? Done. Okay. What form is this? On the left. What form is this? Amanda. Factored. On the right, what form? Expanded. If you look at all of these, they're all being changed from factored to expanded. Let's do one more together.
Who's 3 times x with the x?
No, it's not x times x times x.
Hey, you said 3 times x.
3 times x is 3x.
Times x.
You're thinking of x times x times x is x to the third. 3 times x is 3x. 3 plus x stays 3 plus x. You can't combine it at all. Okay, what about number 2? Kyan, give it to me. What's the set? How many copies are there? I don't feel like making 202 copies of C plus Z, so what's the shortcut? Okay, say it. Okay, what's 202 times C? Correct. What's 202 times Z? Tyler. I can't stand it either. You got to do this because it looks really weird. 202Z. But it is what it is. We got to deal with it. All right, so 3 for 10. You'll do a little bit if there's time in class. You'll go to it. Otherwise, tonight. Should be. Now I'm on page 6, set 2. I'll do the first couple. There are some examples already, but let's do this one. Okay, first column, they want to know whether it's expanded or factored. Tabby? So when you do these, the first thing you'll ask yourself, do I see a common coefficient in both terms? If not, then you'll ask the same if whether you see a common variable in both terms. Do you see a common coefficient? What number? When you see it, factor it out. Chris, what goes inside? Three times what makes 3x? Work backwards. Got my 3. Times what would make 3x? Three times 3 makes 9. I gotta make 3x. Right. X. Michael Lepsy, finish it up. Because I asked. All right, guy. It's an old joke. Here's this big ugly one again.
Big ugly.
Only difference here is there's an extra step. Is it factored or expanded? Oh, my bad. Right, parentheses is going to be factored. Always.
C line through it.
Are you good with it?
Yeah.
Want to try 3?
So, yeah, let's do it.
One more together.
It's factored as the same thing as on the
If it's factored already, you're going to expand it.
No, but it's the same thing over here. This is
For number 2, it wound up being the same. That 202C plus 202Z. This happens to be a repeat. What about 3? Factored or expanded? Nick? Yes, if you want to abbreviate it, you can. Just be careful, F's and E's look very similar. All right, expanded. Who wants to come up to the board and do it? Look at that, speaking a new language.
What the heck? I can't even see it.
Okay, so for the remainder of the period, you could do it in any order that you want. You could finish this up.
Where's the C? Oh, no. Why is there a C?
I did this. I made the same mistake last period too. I did ABC and it's ABD. 18D.
Where's the C?
It's true.
That's a big one. Whoopsie.
Good. We're good. We're recording. We're done.
Yeah, I'm on.
Good. We're recording. We're good. We're recording. You just added another 18 seconds to somebody's date tonight. All right? Okay, so for the remainder of the period, wherever you're seated, it's not enough time to group up. Finish up all of set 2 and all of set 1. You could do it in any order that you want, but this, part 2, is for tomorrow. So save that.
Wait, that's not part.
Nope, your homework is set 1 and 2. Bottom of 5, top of 6. That's it.